Hi everyone, let's start with the essential Python training part 4. In this part we will talk about modules, function, classes, meta classes and some object oriented programming concepts. Uh, Let me give you a brief summary of previous parts. In previous parts we are done with the installation, setup and basic data types and data structures. We have also done inputs, control flow, branches, iterator, generator and a lot of other things. If you have missed those videos, please check in my channel and please subscribe to my channel for regular updates. So let's start. So what is a module? Any directory in Python containing one blank under init.py file it's said to be a module. You can define what files you want to use in that module inside the under init file, but initially it will always be blank, and when it is blank, set to blank, it can use all the files present inside the module. What is the use of the module is, like, once the under init file is defined, you can access the files inside the module of any module from some other module through that under init.py only. So we'll talk about this. I'll give you a live example of module. Let's move on to the next slide. So what is a function? Function is simply some action. If you go to any programming language, function is common, and how that function is defined, it's like some typical behavior or some action or something. Like, suppose there is a human, and there are various action attached to that human, eating, taking bath, brushing their teeth, lot of other things. The same way, the behaviors or the actions that are present for that particular person, you can define that in a function module. Like, suppose you are creating one app for defining one human or artificial intelligence. You can define its behavior through writing the functions, and the the syntax of a function is like def, then your function name, then you pass parameters inside. Like, you can directly pass one parameter, or you can pass star args, or it can be anything, or double star kwargs. Args stands for arguments and kwargs stands for keyword arguments. This arguments is basically taken as a list, and this keyword arguments is basically taken as a dictionary. Let me show you. It's a demo function, which is the same I have told you. Actually, if I execute this file, this will break as there is no body inside. Let me put a pass here and let's execute this. Python 01. It's simply passing that function. If I put a print here, print, these are the behaviors you are defining inside a function, that how your function should behave. Print hi. If I execute that function, it should print hi. Okay, I'm just defining the function. I need to call the function now. So you need to do this, your function name, whatever function you have defined, then execute this. Without executing your this is something of a function definition. Like, you are defining your function should behave like this way, but once you define your action or behavior, you should call that action. So I'm calling that action here, and it should go like this. Okay, it's saying it should take some arguments, but I'm not passing anything, as these are not mandatory arguments. I will talk about arguments more, but for now just put something 1 2 3, and it's printing high. So then moving on to the types of arguments is let's first give you another example which I have put in here also. Like suppose I want to print all integers that are less than 100. So I can simply write like this. I can define a function for I in range 100. So if I put, I'll talk about range in the next few slides. Oh, we have discussed range in the previous slide, I think. Yeah. So when you give 100, it will take from 0 to 100 and it prints them. So let's test. Actually this will not execute because we have defined a behavior but we are not calling it. So now let's call Python 02. So it's printing all the integers starting from 0 to 99, which is less than 100. So let's talk about arguments now. There are 4 types of arguments. One is mandatory or required argument. One is positional arguments. One is variable length argument, and one is keyword arguments. So what are those types of arguments is one is a required argument, which is this. As you saw, like if you have defined a parameter like this and you are not passing anything, it will break. It will say like some arguments is needed to pass. But if I do this is none and I don't pass anything here, it's not breaking because this is some parameter I have defined like that, but I have also assigned none to it. So if I am not passing anything, it will directly take this as none. Okay, so it's kind of not required, but it's default argument. Then the next, so 2 types of arguments are done. Next is variable length argument, which is this. As I have already said, this takes a list, like something as a like list. So let's see 2, 3, 4, 5. Let's see what happens. I have not tried this, which will not break because, and if I print args, let's see what it says, 2, 3, 4. So what it is doing is it's taking one as parameter, which is some value which is 1, and the rest of the thing it is taking as a tuple or a list. As you have not passed anything as a list, so it will take it as a tuple, and it's taking the whole thing as a tuple. Now if I put anything here like name, Steve, and I execute this, so it's executing. But if you print here, print kw, see, name Steve. So how it is differentiating arguments from keyword arguments is, for keyword arguments you need to define these 2 stars while passing it into the function. So we are done with the function. Then there comes something called class. So what is a class? Class is something like a blueprint which can't do anything, but you can create a lot of objects out of that blueprint. So it's simply some plan or something that you can prepare with your class. It's See, in Python, everything is an object. And what is an object? Object is the instance of a class, or something that is made out of class. So one class is written for everything in Python. Like whenever you are going to consider a list or string or anything, there is a class written for that. So you can so it just some behavior of how that object in Python should behave. So let me show you a demo class, which is this. It says my class. I have defined an argument here, and I'll talk about argument more in the next slides. And then I have defined a function here which says hi. This is also the same. It will not execute because I have just defined it. I'm not calling it. So let's call obj, which is object, equals to my class. So this class object is defined. Then I have to call one attribute of that class, so which is obj dot say hi. It's simply returning hi, so I have to print it. So this, let's see how it executes. Python 03 demo class. Hi, it's saying hi. So it's executing. One thing I want to tell you that you might have seen as compared to the previous class files, this class file names are different. Why this is so? Because I want to tell you that like C, you cannot like start your variable name or file name with some number. Means you can start, but it will not execute. While executing, it will give some error. So you should start with it with a character or a single underscore or a double underscore only. So let's move on to the next slide, which is meta classes. As I have told, for every object there is a class written in Python. So how it should behave and all. So what you can do is you can define your own class, some meta class is present for every class, and that defines the behavior of that particular class. At some cases it's at almost not some cases, at almost every cases it takes the meta classes automatically and it defines the behavior. But at some cases you can define it by yourself only, like this example. Let me show you how. If I go to meta class, as you can see, I have defined a meta class type, which is means if you are defining a meta class by yourself, you should pass type inside. Then I have defined instance as none, so it should not create its own instance. Then I am defining the call function, which will get executed at the time of calling. I am passing the class attribute inside this function, so it can access all the attributes of that class. Then I'm defining a super user with a super class, which is parent class, which is meta single, which is some class meta singleton. Basically it should be like foo, or let it be meta singleton to understand clearly, which is some class present which should control the behavior of this function, this class. So I have defined it here, and now what I am doing is I am defining a meta class here inside foo, and I am assigning this. So this is the syntax of assigning a meta class into this. So what it is doing is it's okay, sorry, it should be meta singleton here. So now the behavior of this class should be controlled by this class, which you have already defined. So there is no point of executing this, because as I have not defined anything in this class, it will not give you any behavior of this class, but we will talk about this later in the next slide. Let's move on to the next slide, which is object oriented programming. What basically one object oriented programming is, I told you what is an object is. Class is a blueprint and object is something that is made out of that blueprint. So what is that object? It's something like a package, or so just consider a human body as a object of some blueprint that is being there when a human is created, or like at the start of the universe. So every human being is created out of that blueprint or that class, and every human is an object of that class. So what that object, what that class will be having, it will be having some properties, like its own properties, like it should have 2 hands, 2 legs and all. These are the attributes. Then they have some default behavior, like how they should behave, whether it's whether they are going to speak or not, whether they are going to eat regular basis, or whether they are going to be fat or skinny or tall or very short height or not. They are defined in some behavioral action. Then they will be having their own action, like what they will be doing from the whole day. Like they are sleeping, they will eat, they will sleep, they will ride a bike, they will go, they will learn, they will do a lot of things. So someone will create a class, will define all the actions inside that class. They will define attributes, and then they will execute that class so that a object is created out of that class. Then you can invoke all the actions accordingly, like when needed. So this is the basic thinking of object oriented programming. So what an object oriented programming have in its concept, like this is the basic structure of an object oriented programming. This is one object, as you can see, this is a round spherical thing which has several methods and which have several data, which is private data. Then it has some interface through which this object is going to communicate with some other object. Then they will be having some messages, and they will be communicating, this object will be communicating to other object through these messages only and through this interface only. So these you can see, these are some messages that are already present, which is there for some other class, and which this object is accessing. So there are some few terms that you need to learn, which is class variable, data member, self, init, del, static method, class method, inheritance, function overloading, operator overloading, abstract class, and meta classes. Meta classes you are already done. Abstract classes, and it's not object oriented programming is itself is a huge chapter, so it's not possible to cover everything in this slide. But once our essential Python training course is done, we'll be starting with 1 or 2 videos only meant for object oriented programming in Python. So we'll describe everything. For now, I'll just describe the necessary things that you need to learn doing Python coding. So class variable is, as you can see, there are some variables present for the class that only that class can access. There are some data members which is specially defined for one class only, and those can be accessed by that class and the object of that class. Self is like this function, like it can access its own class. So all the data members of one class is validated through self. Then init is like a constructor. Let me tell you what a constructor is. I have told you about blueprints and objects. When the blueprints is executed, the object is created. But how? there should be some action that defines this blueprint should be executed in this way, so that this things will be done, and out of those, like this object will get created. So that is the work of init, or it says or it is a constructor which constructs the object out of the class definition. Then there is something called del, which is destructor. It's the work of destructor is just the opposite of instructor. It destroys the object from the memory. Then there are something called static methods, which is not dependent on any class. Then something called class method, which can be used through class only. Then there are some concept of inheritance, like you can define some class like grandfather or a person. Then you can inherit that person into some employee, or grandfather into father and child, and like this, and you can define default behaviors. Then there is something called operator overloading, like you can overload the work of an operator. Like suppose I am using plus sign for addition, now I can override the plus sign, and I can use plus sign for multiplication. This is called operator overloading. Then there are something called abstract classes, which is like it will not create its own object, it will not create anything like some behavior or something, but it will be inherited in other classes, and it will define the behavior of those classes. So I have already discussed all these things with you in the previous slide, like the class member, self, constructor and destructors. So let's talk about before that, let's go to here. I'll talk about old style and new style Python classes. As you can see, the syntax of old style is like this, where you don't have this object in here while defining a class, whereas in new style new style classes should get inherited from object or already present new style classes only. So what are the differences is like there are no old style classes anymore in Python 3, and there are like various new features added in new style classes. The MRO, or MRO means method resolution order. It's like like suppose there are two same methods available in parent class as well as base class, so as well as child class. So if I am calling the method name from the child class, which method should get called, or and the second scenario is, like, suppose a child class is inherited from two different parent class, and they have two different function with the same name. So when I'm calling the function name from the child instance, which function it should call, so that resolution is called method resolution order, which is MRO. So the MRO concept is being changed in the new style classes, and so many other features are already added. So now let's get back to the code and check some cool stuffs. Okay, this is the old style class which you have already seen. Let me show you something. IPython. As you can see, let's talk about modules now. This class 4 is a directory which contains one init file, which is a module. So I should be able to import any of this function inside this console. So let me try import 0 5 old style class. then my class name is my class. Okay, it says the constructor should not return anything. Let me print this. Okay, so let's try to return none. This is the like one of the features of old style classes. All the constructors inside should return none. Maybe there is some issue in here. Let's change the function name. It is say hi, and let's print. Okay, actually let's change it. I forgot to tell you that every time you do some changes you need to restart your IPython. So as you can see, this is printing hi. I have not done it, I've just instantiated and it's printing hi. Why? Because I'm printing that here. So this is the old style Python classes. Now see the new style Python classes here. It's the same. Let's see. Import 06 new style class obj1 equals to 06 dot one class. It's the same here. It should as I am not doing anything, it should return something, print new, and it should return none. Let's execute this, which is saying hi new. So there's a difference of old style and new style class structure. As you can see, I am able to import this file name and use the class from that file name only because this under init.py. If it's not there, I will not be able to do that. Let's go to employee. I have created one example for you to see like how the inheritance and all constructor and all the thing works. Like I have defined a class object employee, then I am defining something like employee stamp, which is a time stamp for the current time when this will get executed. Then I'm inside init, I'm just defining some name which I'm passing inside, some age which I'm also passing inside. Then I'm calling one assign employee ID, which is a method of the same class. Then I'm just defining, as this is not, let me tell you one thing, any member of the class that is appended to self is a data member, so that can be accessed from class, accessed by the class and the object of that class. But any member that are not started by that but have some values like this, it will be a class member which can be accessed by the class only. So either you have to pass CLS object inside, CLS argument inside, or you need to directly call the class to get that, which is a static value. Like every time the class will get executed, this value will change, and this will be constant for everyone. So what I'm doing here is I'm just changing it to the current time. Then I'm creating an employee ID which is stamp, comma, the first 3 letters of the employee name. So, and then I'm defining a function report. It will say the name of the employee, age, the age of the employee, years, is assigned to employee ID this. So let's try this function. Python import 07 employee as em. So then just obj emp dot employee. Actually, why is it breaking is you should, while initializing it, so you should pass some name inside, like let's Tony, comma, age is 23. So one object is created, as you can see. Then if I do this obj dot emp stamp, it will give me this stamp, which is for some time period. It's just timestamp. If I call obj dot report, it's a function. It says Tony, age 23 years, is assigned to an employee, which is this, and the first two letters of the name Tony, TO, as I have defined 02. If I define 03, let's see what happens. Let's see. For example, I'll first show you what happens if I do it with Tony, and let's see report. It's saying Ton, and let's see what is the employee stamp, which is 20 and some number ending with 27. Now let's try to create another object out of this class, which should contain Bruce 34 object 1 dot employee stamp, which is some number ending with 54. So as you can see, now this stamp has been changed, which is unique. But if I'll not do this, it will be same for all instances that I will create. So let's see object 1 dot report, what it says. Report Bruce, age 34, is assigned to employee ID Bruce. Okay, so let's now do one more thing, which is exciting. I'm creating some class called developers. I'm importing employee, as this is one init file present in this module. I can import any file inside some other file. So I'm importing the employee here. Then I'm inheriting developer with employee. I'm defining a static variable as developer. Then I'm just doing something like I'm defining a property employee type is return this. So by doing this thing, I'm defining the employee type of this function, which cannot be changed. Like if I want to change this, it will not allow me to do that. Then inside init, what I'm doing, whenever I'll try to create an object out of developer, it will invoke the init method of the super of this class, which is employee, and it will invoke the init method of employee. So this is very exciting. Let's see. Let's break it first. Import 08 developers as dev. Number is object. It's breaking. if I pass this, as you can see, I have not defined anything in the init. So if this will fail, it will actually not call anything for this class, but if this works properly, it will call this init function from some other file. So let's see, I'll pass here Natasha, comma 22. So one object is created, and if I put obj dot employee stamp, as you can see, there is no employee stamp present for this object, but I can call it and I can get some value which is giving me the value of the parent. I can just put employee dot emp type, which will give me developer. If I just try to change this from developer to HR, it will not allow me to do that because it's means I have defined it as a property here. Now if I want to do like obj dot report, it will tell me Natasha, age 22 years, is assigned to employee ID net. So I hope you are a bit familiar with classes and functions and modules now. So that's all for today class. We will talk about more on various other things which are like almost that those things are told at the end of every programming language, and once those things are done in part 5, I will release that video, and then I will release some other video whose name which will be like things that I have missed in all the 5 parts. It will be a summary of very short video, and stay tuned for that video. We'll talk about this more soon. Thanks.